Okay, so for number 21, a block is on an incline with friction, and it's given an initial velocity of 8 meters per second. And after 3 meters, it stops, so its final velocity would be 0 meters per second. And part A wants you to find the change in the block's kinetic energy. So we know that work equals change in kinetic energy, and change in kinetic energy is K final minus K initial. And since the block has a final velocity of 0 meters per seconds, the final kinetic energy will be 0, so you're left with negative K naught. And you just plug in the values that they give you. They give you mass, and then they also give you the initial velocity, which is 8 meters per second, and then uh, plugging that into your calculator, you should get negative 160 joules. Okay, so for part B, they want you to find the change in the object's gravitational potential energy, which is also work, since work is a change in any energy. So you have potential gravitational energy final minus potential gravitational energy initial, and I set the h equals 0 point at the ground, so that's where the object initially is, and so it won't have any gravitational potential energy at that point. So you're just left with mgh final, and the change in gravitational potential energy measures the change in vertical height, but they do give you like the hypotenuse of the triangle. So to solve for the height, it's really easy. Just do 3 meters sine 3 meters times sine theta, which is 30 degrees, and then you should get 1.5 meters. And then this is the height that you plug back into this equation over here. So you have 5 kilograms and 9.8 meters per second squared times 1.5 equals 73.5 joules. And now for part C, they want you to find the force due to friction. And friction here is a non-conservative force, so in like the statement of energy, the work due to friction is non-conservative. So to solve for that, you want to isolate this. You want to isolate this term, so you'll get K work non-conservative equals K final minus K initial plus UG final minus UG initial. And then this simplifies to the change in kinetic energy plus the change in potential energy of gravity. And we solve for those both in A and B, part A and B of this problem. So the change in kinetic energy was negative 160 joules, and the change in gravitational potential energy was positive 73.5 joules, and that equals negative 86.5 joules. Okay, and so work equals force times distance, and they're asking you to solve for force here, so that would equal work over distance. And then the work we just calculated was negative 86.5 joules, and then the distance the object is traveling is 3 meters up the incline, since we like tilt the axis when the object's on an incline. And this equals negative 28.83 newtons. But since the problem's just asking you for the magnitude of the force due to friction, it's just 28.83. And finally, for part D, they want you to find the coefficient of kinetic friction. So we know that friction equals mu kinetic times normal force, but here, since the object's on an incline, the normal force will not equal mg, but it'll equal mg cosine theta. So to isolate the kinetic coefficient of kinetic friction, you should get F over N, and then we already know the value of the frictional force from part C, so that's 28.3 newtons. And then on the bottom, this normal force is equal to mg cosine theta, so that's 5 kilograms times 9.8 meters per second squared times cosine of 30 degrees. And this should equal 0.679, and that's your coefficient of kinetic friction. And that's it.